To do box plotting, I go for analyze, descriptive statistics, explore. In this already we have used statistics. Let me take the button outlier. In plots, I want histogram and normality of the plots. Continue and say OK. Scroll down to the output window. I have this graph which is called box plot, which explains about the data distribution. You see, this is having a box with a thick line in the middle and having some strings up and down both sides. The box, what we see in a color, this is called Interquartile Range, and this string is called whisker. Now this is a box plot where we have, this is IQR, interquartile range, this is upper whisker, this is lower whisker. The circles, when you see, this is called outliers, which are above the range of the whisker, and extreme behaving cases are indicated with star. The middle line, which is thick line, is a median. If you see this graph, we understand that B is having complete range starting from 0 till 100. That's what we said. In 0 is a minimum, maximum 100 is there. A is having minimum 0, maximum 76. Its medium is 11, whereas this medium is around 22. Now we understand from this box plot how the data is distributed. The same thing we can see in the descriptive analysis. This is what we see, the descriptive analysis about its minimum, maximum, which whiskers, its a median, its interquartile range, these things with the box plot. Apart from this, we have two more things. Skewness and kurtosis are given. In histogram, when you talk about skewness, it shows how the data is skewed, whether it is in the middle or it is skewed to right side or left side. When it moved to left side, it is minus. If it moved to right side, it is plus. Kurtosis explains the peakness of the graph. Now if you see here, skewness is 1.185, kurtosis is 0.010. Now using this data, can we say whether kurtosis is skewed, the histogram is skewed or not, or kurtosis is more peaked or not? How can we say that? We can explain this with a small calculation which need to be done manually. The data from SPSS have taken for box plot block A. Skewness is 1.185, kurtosis is 0.010. Its standard error is 0.512 and kurtosis standard error is 0.992. We multiply this value with 2, we get 1.024. Multiply 0.992 with 2, we get 1.984. These are the two values. And whether the histogram is skewed or not, to know this one, what we need to do is, if the skewness value is less than this value, we call it is not skewed. If the value is more than this value, then it is skewed. In this case, if you see 1.185 is more than 1.024, mean the histogram is skipped positively, positive sign. Now kurtosis also same. Take the kurtosis value. If the kurtosis value is less than 1.984, then it is not more peaked. So in this case, kurtosis is not there. It's not too much peaked. It is within a limit. But the histogram is skipped. This is what we understand. The skewness value must be less than 2 into standard error of skewness value. And kurtosis value must be less than 2 into standard error of kurtosis value. This shows whether the histogram is skipped or not, whether the histogram is kurtosist or not. These things can be understood from the values, and this need to be done manually calculation. Manual calculation need to be done. So this is the data which we have used just now. In the same way, we must do the analysis for block B, C and D to know that whether the histogram is skipped or kurtosed or not. But the main thing is whether the histogram is normally distributed or not. This is important. To know this one, we need to go for test of normality. This is a table which is called test of normality, where we will be having Kolmogorov-Smirnov test, where we have significant values given for each block. A block is having 0.001, B block 0.041, C block it is 0.048 and D block it is 0.2. So to understand whether each block data is normally distributed or not, we will do the analysis. This is test of normality. I have extracted this table from SPSS. I am going to maintain a hypothesis. The data is normally distributed. This data belongs to block A. The hypothesis, the data is normally distributed. I kept a rule. If the significant value is less than 0.05, then reject the null hypothesis. Significant value means the highlighted red color. This is called significant value. Decision is the significant value of block type A value is 0.001. This is 0.001, which is less than 0.05. So I need to reject the null hypothesis. Conclusion: block type A data is not normally distributed. Means block A is not normally distributed. But if you see block B, it is 0.041, again which is less than 0.05, so not normally distributed. If you see C, it is 0.048, which is again less than 0.05, so block C is also not normally distributed. But D is having 0.20, which is not less than 0.05. It means I am going to retain the null hypothesis. It means block D data is normally distributed. The data of block A, B and C are not normally distributed because we are rejecting the hypothesis. Block D data is normally distributed because 0.2 is more than 0.05. So I am accepting the hypothesis value. Coming back to SPSS output screen, I said block A is not normally distributed. It is not normally understood. It is more skewed towards one side. B also has the same problem. It is not skewed. Skew means it will have a bell type of structure. Block C is also not having normal distribution. Pretty much block D is having normal distribution. is having normal distribution. This can be understood using QQ plot also. In QQ plot, if you see block A, this is observed value, straight line, expected value. They're not having synchronization is not there. If you see B, synchronization is not there. Then they're not aligning with the line. If you see C, they're not aligned. But you see D, the lines which are expected is totally aligned with the line. So this only D block is having normal distributed, whereas C, D, C, B and A are not having any sort of normal distribution. This is a exploratory data analysis for the given data. I hope this video is useful for you to understand the data analysis. Thank you.